Hey there, ho there, hi there, folks. In this third video of going over how to do beat detection, I'm finally going to get to the part where we do some beat detection. So in the first video, we displayed the waveform. In the second video, I added some controls for playback and, skipping forward and backward. And this is what we have at this point. The yellow line is the waveform, and I could skip forward and backward, and I could play and pause, play, and pause. And I could zoom in and out with the mouse wheel to see the entire waveform. Okay, so let's see what we got. First off, I think I'm going to increase the meter scale so that the heights are taller. And let's see what that looks like. Yeah, that's better. A little bit taller heights there. All right. And I could see the whole waveform here. This is dun, duh, dun, dun, duh, dun, duh, dun, dun, duh. And that's the sound of this song. So with my eyes, I could see that this is the beat, this is the snare. This is the beat, beat, doubling up. This is the snare. This is the beat, this is the snare. This is the beat, beat, and this is the snare, kind of. That's what I see with my eyes. How do I get the computer to see that? Well, first thing I'm going to do is I'm going to use something that Unity has. When I do a line, there's this thing here called tolerance and simplify. So Unity has the ability to simplify the line from being real jaggy to kind of reduce it down to some more necessary points. So I'm going to use that to help me find out where the beats are in the song. But before I even do that, I probably want to be able to see what the song data actually is. So let me go to my script that we had been working on. All right, and this is the script we've been working on. We were using link for doing things like, and we have an array that we could select something from the array with the select command and just select one of the values from the object. And I also used it to find the current point. So the audio gives me back a timestamp, and I use it to find the current point. Since all my points had the start and end sample, I just look for a time sample between the two. So I use link for that. And another thing up here that I added was using system IO. And this is going to be so I could write output to a file. Now we could always write output to the the console window over here, but it's going to be a lot of data that I'm going to output because I'm going to output values from the point data that I have. So let me add another function down here, and it's going to be called, I'm just going to call it debugging, because really that's all I'm using it for. And what its job is going to do is to output something to my asset folder. And the name of the file is going to be debug.txt in my output folder. So this streamwriter thing comes from system.io.streamwriter. See, but since system.io is up there in my using statement, I could just actually say streamwriter without the system.io in front of it. So that will be equal to a new streamwriter using the path supplied. And do I want to make a new file every time? Let's see, that's 3. We got one with the path, one with the stream. So I had the path here, stream, path, and append. Okay, so appending, no, I just want to make a brand new file every time I call this function. There we go. And then SW will do all the writing out to the file. And then at the end, I'll have to close the file. So let me just put the bottom of the function here, SW close. And then I want the file that's in the asset folder to be read into the Unity editor so I could see it and open it from there. So I'll say Unity editor is the object, dot, the asset database. This is like the thing that every time I add a file to the folder that Unity knows about it, and I'll say import the asset that I just made, the file. Okay, and then this command will show it in the Unity editor window when it makes the file. Goody, goody, goody. Now I just gotta write stuff to the file. So let's start off. The first thing I guess I want to write to the debug file are details about the song. So I'll say sw.writeLine. This is details about my song. All right. Okay. And then what details do I have about the song? sw.writeLine. I'll just have the details here. So just start off with, I'm just going to write the song and how many samples and channels. I'm going to see if this debugging thing works. So what am I going to call this debugging function? I guess I'll do it in the start function after we set up our song object with the data and we read from this and all this and that. And just before the start function finishes, we will call debugging to output what we just set up so we could get the values here. So with that there, this call to debugging and the debugging function here, let's see if this works and actually makes an output file for us to throw information into. So there, I'm going to run and there you go. It did make the output file. Now let's take a look at it. Let's double click on it and there you go. Song, samples, 176,000 samples, 2 channels. All right, so that means this is a stereo, and that's going to be about over 300,000 samples that this short little song has in it. So there we go. All right, we got something to output to. So now let's start. And you know what else? I'm probably going to see what does the data look like in the points. So let me do another one for points. And okay, so I'm gonna have the points here. It's gonna see how many I count. And what I'll probably do is go through each point for each point data. PD and song.points. I'll probably do a sw.writeLine PD.toPoint. I'll make a function for this. Okay. And for each of these points, I probably want to add a tab to indent it like I did above, plus whatever the point thing is. Now, I didn't write this point function yet, so let's go to the point data class that we have in our helper, and let's add a function, public string to point, and in this, we'll just put everything we want to show about these values here. So I'll use a system.stringbuilder system.text.stringbuilder sp1 equals a new string builder, and then the n sp1.toString is what I'm going to return. Okay. Now in the middle, I just got to build it. So let's see, we got the index. So let's do string sp1 dot append format, and we'll say IDX. Oh, you know what? Let's make a line that's a heading. So in the 2 point, I'll say bool if it's a heading or not. All right, so here I'll say if head equals true, then I do a heading line, and else I do the data line. Okay, so here in the heading, I'll return, I'm just gonna magically have this stuff type in, so you don't have to like bear with me with it. Okay, so what I did here was I added a 2-point function so that for every point I could say what to display. What I added was a variable here, head. So if it's the heading, I will just say what each of the columns are. And I'm using pad so that everything takes up a fixed width. And then if it's not heading, then it's going to be the actual values. Okay, now there's a little function I made here, line up decimal, which is just going to take a float value and try to make sure the decimals line up when you read it in the data. So if I use val to string f0, that's just the integer part of a decimal. And then over here, if I divide modulus 1, and I take that, that's going to be the decimal side of a decimal. And so that the sign is not added to it, I just say math absolute value because I'm going to have the sign over here. So I don't want the sign over here. And then I look at it out to about four digits out for the value. Then I return the left plus the right. Okay. So let's see what happens when I run the code with this 2-point thing. And in the debugger down here, I just have a loop, right? So I say points, that's my little heading, and then I write the heading line over here. So I just take any of the points and say point true, it's going to be a heading. It's not going to show the values. And then over here for each point, I show the 2-point, but not the heading, so it shows the values. Okay, so this should work. Let's go now into Unity and see if that output works for us. So I'm going to press play. And the bug file is there. Let's see what it looks like. Open it up. And this is what it looks like. So for song, I have that. And then for points, for this little loop, beat loop, there's 345 points. All right. And this is the index of the point. This is the time that it says the point occurs at here in seconds. These are the samples you see. So since I'm reading 1024 samples each, this is 0 to 1023, 1024 to 1047, 1048. See, so nothing overlaps here in the samples. And then these are the values. And it looks like my lineup decimal is working right here. That's nice. That way when I'm looking down, I could see that the values go up and then down and up a little bit and then down. So this is just looking at the numbers. All right, it's going to be helpful for us to check out stuff. Now let's go back to actually our code. So now that we have something, we have a function here that we can output the values to. Probably what I want to do is have this have a little space there, so /n. All right, so we have that debugging function there that we can always go back to, and here we have our update function. So what next we want to do is some more processing. So here we were reading the reading our points, our song samples into a couple of points. And then over here, we were getting our child objects, our child game objects. And then over here, we were displaying the waveform. Okay. And then over here, we were making the bottom and the start position. Bottoms, size, and start position. We were setting those two things. So this function looks kind of busy already. Let me just add something over here, like I added a call to debugging. What I will do is I will add a call to do the simple line. So I'll call this function simple line. Okay, and I'll just write it over here, private void simple line. And what we're going to do is we're going to generate a simple line from the waveform line. So that would be, this waveform line is the yellow line that we're going to see here again when I press play. Come on. Come on. There, this yellow line that's kind of jaggy and stuff like that. We're going to make a simple line. So hopefully you just get like a up, down, up, down, up, down, up, down, you know, something like that. Simplify the line out. So on the song thing, the simplifying of a line, if we look at a line object here, it has a tolerance value. So for our song, we're going to be able to provide a tolerance value. So here in public, we had meter, zoom, skip forward, skip back. Let's add another thing here called tolerance. And initially, I'm just going to set it to 20 to see what that works like. The bigger the number, the more the line gets simplified out. All right, now this yellow line is our waveform. Let's make a copy of this and just keep it together up here. And the second line, this will be our simple line, so I'll call it simple. And we will have it at a different color so that, we have a contrast between the two. So, I don't know, let's make our simple line like, I don't know, green, whatever. We could always change the color. Okay, you'll make the simple line green. All right, and now back in the script, I'm gonna need a pointer to that. So that was the line. Let me have public line renderer simple. And yes, I did spell this wrong. Thank you for telling me. There, simple. And then over here where we're getting our objects, let's get that simple object. Object.simple.equals, get the child. The name is simple, and the parent is, what is the parent? I think it's the start. Just to make sure, simple's parent is start. All right, so object start.transform. And we have to get the line component of it. Okay, line renderer. There. And something's wrong because simple line renderer. And I spelled something wrong here. Get component. Bam. There we go. All right, so let's see. Here we go to simple line. So to do the simple line, there's a thing called line utility. Okay, from Unity, there's something called line utility, and it has a function called simplify. So I give it the points of a line and simplify them. So let's see what it takes. We are going to use this one here where it takes a list of, not vector 2s, vector 3s. It's going to take a list of vector 3 points, the tolerance that we just made a variable for, and a list of int. This is going to be the points to keep when it gets simplified. So I'm going to need over here a list int, and I'll call it keep equals new list int. Okay. And then the first parameter, what was it again? It was a vector 3 of points. So let's use our link lambda expressions again from our song.point dot. We just want the vector 3s here. So we'll say x, or x is vec3. Vec3, and that gives us points, and it wants an array. So we'll convert that to an array for the function. That's our first parameter. Then the second parameter was tolerance, and we made a variable called tolerance for the inspector window. And then the next one is the keep. So here's the keep. So something's wrong here. It says vector 3 to cannot convert Unity vector 3 to system collection generic list. Oh, I made it an array and this wants a list. Fine, we'll use the toList method. Okay, there we go. Everything's nice. So keep. What simplify is going to do, out of all these points, it's going to give me the indexes of the points to keep that make the simple line. So now I just have to go through and probably flag each of these points to be simple. So what I'm going to do is I'm not going to make copies of my array. In my point data, I have these objects here, these variables. So what I'm going to do is, let me just make another structure here. This is a function, this is a function. In the point data, song data, child object, I'm just going to make another structure just to keep things neat, and this is going to call flag data. And the first flag I'm going to have is simple for a simple point. All right. I'm going to have other flags. That's why I'm making a structure. So wait a minute. This has to be a public bool simple. And Maybe I shouldn't do this yet. Let's only make things more complicated when they have to get complicated. So I will just add here a public bool is simple. All right, that's simpler. And by default, it is false. This is not a simple point. Okay. Now when I go back here, I could use the keeps to mark all the points that I want to mark as simple. So for int I equals 0 to I less than keep dot count I plus plus. Okay, so song dot point at keep at I. All right, so keep has a value. So let's make it int. Let's call this k. Let me rename this to k. Rename this to k for the keep index, and then I'll say that the actual index equals the keep at k. Okay, that's going to hold the value of a point that we're going to keep. So then I'll say song.point at index dot, what's going on here? Dot is simple is going to be marked as true, that this is going to be a simple point. So it's going to go through all the points and mark all the ones that it said to keep. The ones that are simple, I'm just going to mark them all as is simple. Okay, now that I have points that are marked simple, now I could use, again, I could use lambda expressions to do my simple line. So object simple dot position count is going to equal how many points I keep. So I have that keep thing. So keep dot count. Okay, and now the points that I actually set for the simple line are going to be set positions, and I'll use the lambda expression thing. Song dot point dot where x, where x dot is simple equals true. Okay, and that's going to give me an array of points, and I need to convert them to oh wait, I just need the positions of it. So select just the x where x dot vector 3. Whew, and then we have to convert that to an array, I believe. Yeah, we'll see if the red line goes away. Bam. Okay, good. Yeah, because set positions wants a vector 3 positions array. So this part, the where, gives me all the points that were marked as simple. And then from my point class, I will just select the vector 3 and make those an array of vector 3s. Okay, so this here should make my simple line. So let's see, press play. After the reads the process of the script, now I press play. And I should have 2 lines, and something looks wrong already. That line is just 2 points. Why is it just 2 points? Is it actually 2 points? Let's see for the positions here. It is just 2 points. Is my tolerance too high? Is that what it is? Let's see, in the song, I could set the tolerance. Let's set it to 1 and try it again. And now you can see that the yellow line is got a little bit of jaggies, and then my simple line, which is simpler, if I hide the yellow one, is the green with less jaggies. Okay, so I think we're getting somewhere. Let's try for our tolerance, let's try it at 10. See if that works. And that didn't work either. It's too high. Let's try it at 5. Play. Okay, we got one for here, one for here. This one it skipped out. We got this for this the snare, and then we got, this is the double beat, but it has it as 1, 2, 3. Yeah, it's kind of iffy. So I have to play around with the tolerance and get a nice value. Okay, so what I wound up doing was I increased my meter scale to 300. These numbers you could play around with. and then I set my tolerance to 9. And then what comes out is something that is as close as I can get, I think, right now. So this is the dunk, then this is the snare, then this is the dunk dunk, got like 2 beats there, and then the snare, it didn't even catch, and then the next one, dunk, and then the snare, and then dunk dunk, and then the snare. So if I play it, it has some of the points, but not all of them. So my first level here, I'll say for this percussion thing, I have it with something that works. And let's see if we have the data show that. We're going to have to add something more to the debugger, the debugging thing. Since the points is kind of like the biggest thing to show, you know, it's the longest thing, I'll leave that in the bottom. And in the middle, I'll just add another thing here for the simple points. We'll see what they're picking, the values. All right, so here in the debugger, I'm adding to show the simple points. So I'll use link to just select the points where X is simple. All right, and then I'll write the header again. And then here when I loop through, I'm looping through not all the points, but here are the points where is simple is true. Okay, so if I run this, let's see what happens. I'm going to run it. And there we go. And let's take a look at the debug file to see what the data looks like. And there we go. So for simple points, we have only 18. And we could see the values here. It goes up, down, up, down, up, down, up, down, up, down, up, down, up, down. So we're getting there. We have the simple points. The next thing I want from the simple points, let me just run this again when I look at it. When we look at this here, is, you know, there's 2 points. There's the up, this is a peak, and the down. So the down is not going to be where I am thinking a beat is. I'm thinking the beats are going to be on the peaks. Okay, so from this line of simples, I just want the peaks, the ones that are on the up. So now we're going to write some code to show that. And I'm also going to show the peaks. So let's go back to the script. And let me just collapse definitions, see what we got here. All right, so now we're going to have to mark something in the here, public bool is peak, or is, I'm going to say that the beats are where the peaks are. And by default, they're false. So I have another flag here, is beats. And let's think. So I guess the first thing I'll do is I'll make a function for the peaks. Plug void peak calculate. And then I'll have this be called from start as well. After the simple line gets called, then I'll call peak calculate. Okay. And in peak calculate, I want to go through all the simple points. I want to go through the simple points. So let me just get an array of the simple points here. Equals song.point dot where x dot is simple is true to list. Okay, so then I'll go through that list for int I equals 0 to I less than simple.count I plus plus. When I'm going through this array, I'm going to set a value for beat. And so if I'm at the first point, if I equals 0, then I'll do, what will I do? If I equals 0, so if this first point is up, if simple at I dot val is greater than simple where's my if? Oh, if simple at I dot val is greater than simple at I plus 1 dot val, then, I'll mark this one as a peak. So simple at I dot is beat, I'll say is true. All right, so I'm really looking for the beats here. So let me rename this to beat find, okay, is beat. All right, that's when it's the first value. If it's the last value, if I equals simple dot count minus 1, we're at the last value, then the way I'll see if it's the peak is if simple at I dot val is greater than simple at I minus 1 dot val, then this last simple is a peak. Simple at I dot is beat equals true. That makes sense, right? Now everything else is in the middle. Else, so I could get the both sides. So if simple at I minus 1 dot val is less than simple at I dot val, good. And then on the other side, and simple at I dot val is greater than simple at I plus 1 dot val, I plus 1 dot val, then we are going to say that simple at I is a beat too. There, so that should mark all the ones that are beats. All the peaks are beats. Now I probably want to show that on the screen somehow. Now that I went through this loop and I marked all my beats, I will have my peaks. So somehow I'm going to have to make some kind of visualization on the screen for my peaks. Let's do this. Let's, in the point data, let's hold a game object that's going to be like a quad. Okay, that would be a big line that we could do. Game object, and we'll call it a marker. Okay, by default it's null. But if I want to show that quad, I'll create the quad, and I want to show it for all these points that I marked as a beat. Let's make a function to create the quad. Void, or maybe game object. The game object is going to return the quad object. Create marker. And what should it take to create the marker? We should take some values, and let me think about this. We should definitely take the position, vector 3, where we're going to put this. And we should also take maybe the color. So we can set a color for it. And a name. So we can set a name for it. All right. Create marker. It's going to return a game object. So inside we'll say game object quad equals game object dot create primitive type dot quad. Okay, so I'll make it in the scene. Then the quad dot transform dot parent. What we're gonna make the parent of these quads. Let's see, there's going to be a lot of them. There could potentially be a lot of these quads, and they must start from the start. So what I think I'll do is I'll make another object here just to hold the quad so this thing doesn't explode. And this, I'll just call it the holder. All right. Oops, what am I doing? Yeah, save it. I'll make a holder, and then I'll make in my child objects, another object here called the holder. Okay, And then we'll have to get the pointer to it in my initialization here in start function. Object.holder is going to equal get the child. Holder, comma, object start dot transform. Okay. So now in this create marker, I can say that the parent equals object.holder.transform. Now the position is going to be quad.transform.local position. We're using local because this is a child object. Equals the pos that the person passes in, and the size quad.transform.local scale is going to equal a new vector 3. Boom, 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 boom. So the points are 1 each, so that's a width of 1, and a height. I don't know what's going to be the height. I had the meter scale. That's probably going to be too big. Let's just try setting it now to 50, and we'll see what it looks like. And 1, okay. And now for the color. So I'll go to point material. We got to make a material of the color. Shader.find a standard shader. Okay. And then I'll set that color equal to the color they pass in on this material. And then I'll have the quad dot get component renderer. I'll get the renderer, and I'll set the renderer's material equal to this nice colored material we just made. And then, they want to give its name, so we'll say the name equals name. And then we'll return this new quad that we just made. So this function will make the quads for us, okay? It'll make the markers for us. So now here, every time I said there was a beat, I'm going to make a marker for it. So this isn't going to be a one-line if statement, so I'm going to have to put the brackets. Or, hey, what's that? I don't want to rename anything. Maybe I'll keep it simple. This will do all that. And now, after I got all the beats, now I'll just loop through them. So, list point data beat equals zone.point.where x is beat is true dot to list. And now for what to do for int I equals 0 to I less than beat count I plus plus beat dot marker equals, well, I'll have to say if it's not set yet. So if beat dot marker, hey man, where is it? Oh, beat that I dot marker equals null. Then I could actually make a marker for it. So beat it I dot marker equals create marker. The position will be the beat at I dot vec3 straight actually, and the color will be color dot black, and the name will be beat. This is a beat I'm marking, okay? All right, so cool. Find the beat. It takes all the peaks of the simple. To mark as beats. And then over here, we just make a marker for each beat. So we can see where the beats are. All right, there. That's the beat find right there. Let's see if it works. So I come over here, Unity processes the script, and I press play. And I don't see any markers, but I do see an error. So that's a good clue there. Index was out of range. Index was out of range. Right here, I minus 1, I plus 1. Why does it go to out of range? Simple count, simple count. Why is it getting out of range? All right, so if I is 0, it does this. If I is the last one, it does this. Then anything in the middle, I should be able to do a minus 1 and a plus 1. So did I type something wrong? Simple I minus 1, da 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 da. All right, let's check what happens here. I come in, if I equals 0, it does this. Then I gotta say else, if I equals simple count minus 1, it does this. Then else, it does that. I had these if, I missed this else over here on the if. All right, so let's go ahead and try this again. Hello, hello, wake up. Okay, I'm gonna press play. And good. There we go. So a peak is here, and I got a mark for the beat. And there's a mark on that peak, that peak, that peak, and that peak. So all the peaks have a mark. Now the only question is, what does that equal in beats per minute if I use all those marks as a beat? So one more thing here, after we marked all those beats, and now we're going through the beats, we probably could try to figure out what the beats per minute are. So I'm gonna make another little structure here, private struct, not strict, struct beat data. And what I'll have is a public float delta, the time between two beats, and a public float actual BPM that the delta calculates out to. And then I'm going to do something to that float, a quantize BPM, like a rounded off BPM that, you know, I kind of reduce the fraction down to something meaningful. So I'm going to have this beat delta value in here, and in my point data, I'm going to add that. I'm going to add a public beat data, and this is my calc beat, okay, the beat that I'm going to calculate. Good. I'll have that in there. So let's see. Let me just shrink everything down, collapse it, all right? This other thing I said here about there's the actual BPM that's calculated straight off the delta, and then there's the BPM. All right, we'll see what we get to that. First, here in the beat find where I marked things as beats, and then here I'm looping through my beats only to get the markers. Well, just keep it simple to read, even though I'm making 3 loops. Now I'm going to calculate the BPM from the beats. So I'm going to loop again here. For int I equals 0. Just to keep it simple, I'm separating the loops, but you know, this probably all been done in one loop. I plus plus. Now in this one, I'm going to use these ifs again because I'll have to know if I'm like the first or the last or anything in the middle. Okay, so if I'm the first beat, what do I do? If I'm the first beat, I can't do anything because I have nothing to compare to yet. Now when I'm at this is the last beat. So this is the first, this is the last beat. At the last beat, I could do something. I don't need those comments, sorry. At the last beat, the beat at I.calc.delta, the time between this beat and the beat before it is beat at I.time minus beat at I minus 1 dot time, right? And then the beat at I dot calc dot actual BPM will equal, there's 60 seconds in a minute, and we're doing beats per minute, divided by the beat at I dot calc dot delta, right? And the beat at I dot calc dot BPM, we're not going to have that set yet. We'll have to make a function for that. So the only time that we can't look back a beat is if we're on the first one. So I could just do this. And if we're on the first one, we do nothing. So basically, if I just start from 1 instead of 0, then I could just do this. Okay, there we go. Now, after we get all those beats with actual BPM, we can see what this looks like. So we're going to have to go to our debugging function, and we're going to output more stuff in our debugging function. So the thing we're going to do more of here, let's just grab this and make a copy. So the beats should be smaller than simple, so I'll put beats after song instead. And beat, and where is beat is true. Heading, where is beat is true. And then prints the data. We got new data now, so let's go to our toPoint method in our point data class, because we have as beat, we have simple. So it'd be nice to know what are the calcs, you know? So over here, we'll say if is, no. For the heading, I'll add some new stuff here. Okay. All right, so here to the heading, I added these 3 new things from the calc. And in the data, I add these 3 things from the calc. All right. So that should show up when we do the, when we make the debug text file. So let me just see what happens. Uh-oh, what's this error message here? Oh, that's typed wrong. Is beat. There we go. Now let's try to build that again. Build. Good. Now, let's try this again here. Play, just to make the debug file. Okay. And now let's take a look at our data. All right. Yeah, so we got 8 beats. Simple as 18. And in the beats, here we go. We got deltas of, which says 123, 126, 258, 75, 62, 258, 235. That's what these deltas represent in beats per minute. Oh, okay. Now let's go down to the code. Right here. Let's make a function that takes those high numbers like the 200s and stuff like that, and let's make a function that could kind of quantize everything down to a range of BPMs, you know, because basically 60 beats per minute is the same speed as what? 120 beats per minute. It is the same speed as 240 beats per minute. It just depends where you're putting the beats and how fast you're counting them. So let's call these 2 variables public float. Let's call it quantizing high. And we'll say that our high value is 160 beats per minute. Okay. And then we'll have a public float quantize low, and we'll say the low is I don't know, 80. Okay. Okay, so we got our beats per minute between those 2 points. Now we make a function that actually does something with those 2. Let me collapse everything, see where I put this. I'll put this down here. Oopsie, what did I do? Enter. Private. This is going to return a float. And quantize BPM is going to be the function. And what it takes is, it takes in a BPM. And it's going to return a quantize BPM between the quantize high and the quantize low. All right, so if the BPM that they sent in is greater than quantize high, then what I'll do is I'll just go through a while loop and keep on dividing it until it's in the range. So if BPM is still greater than quantize high, then BPM times equals 0.5. I keep having it until it falls in range, and then after it falls in range, I can return the BPM. Okay, so that's if it was too high. Now if it's too low, else if BPM is less than the quantize low, then what I will do is the opposite. While BPM is greater, while BPM is less than quantize low, then I will just keep on BPM times equals 2. Yeah, 2. Until it's high enough, and then I'll return that BPM. Return that BPM. And if it's neither of those, then I just return the BPM because it's already in the range. Okay, it's already a quantized value. So now let me go to the beat find function over here in my third loop. And now BPM, instead of equaling 0, it could equal quantize BPM beat at i.calc.actual BPM. Okay. Now I'll just do the average of all those. So I will say beat dot average of x dot calc dot BPM. This average thing is another thing, part of the link. Okay, link lambda expressions. Okay, and link lambda expressions, we needed to use this using link over here. Where am I? Right here. So this will be the average beat BPM. So let's store that average BPM somewhere. Let's put it on the song. So over here we will say public float BPM. Okay. And then that way over here we could say that the song.bpm equals the beat average. We got to wrap this up. This is getting too long here. Let's go. So here we got samples, channels, samples per point, and we might also show what the beats per minute is. Equals a number, comma, song.bpm. Bink. Oh lordy, what's the BPM going to be, folks? Will it be 120? Let's find out. Let's press play. And what's the BPM going to be? Let's look here. It's 112, which is wrong. All right, we've been going through for 53 minutes. What we'll do is we'll come back to this in one more video trying to fine tune this, because it said that this 120 was 112. Then there's this very fast one over here, 140. Let's see what it says that is. Press play. Okay, and let's see what the BPM it says that is. It's 111. Yeah, so the beat detection isn't working yet, but we'll work on the next video on tuning that up a little more, because this video has been going on pretty long and we have some things to work out. See if you guys could figure out what's wrong or how we can make this better before I get that next video up. See you later.